In this video, we will cover the concept of memory segmentation. So what do you mean by memory segmentation? Suppose if we are considering the computer memory, then we have one hard disk and the whole hard disk is divided it into multiple different drives, multiple different parts, and that parts are called as a drive. Suppose you have in your machine C drive, D drive, E drive. So that drives are used for organizing your information or organizing your data. So the memory in 8086 system is organized as a segmented memory. So that's the technique that is called as a memory segmentation. So what is the definition of memory segmentation? The division of computer memory into different parts or different sections, that is called as segmentation. In case of 8086 system, we are organizing and we are dividing our memory, that is segmented memory, into different parts. That parts are called as a segments. So each and every part will be considered as a segment, and that segments are also known as a logical segments. So our whole physical memory can be divided into different number of logical segments. That's the concept of segmentation. Now see, this is the block diagram for our memory segmentation. As we already know, 8086 system, 8086 microprocessor is having 20 bit of address bus. So 20 bit of address bus means 2 raised to 20 is nothing but 1 megabyte of memory. So our 8086 microprocessor consists of 1 megabyte of memory, and the whole 1 megabyte of memory will be divided it into multiple sections or multiple segments, and that segments are extra segment, stack segment, code segment, and data segments. So our whole memory is divided it into 4 parts, and the parts are ES, SS, CS, and DS, that is extra segment, stack segment, code segment, and data segment. This 8086 works with 464 kilobytes of segments. So each and every segment size is 64 KB, as well as it is also known as the 16 bit of our segment register. And the 2 raised to 16 is nothing but 64 kilobyte of data. So the maximum size of the segment is 2 raised to 16 is equal to 64 KB. So in case of a memory segmentation, we are dividing our whole physical memory into different sections or different segments. Likewise, our whole 1 megabyte of memory, that is 2 raised to 20, is nothing but 1 megabyte. And that 1 megabyte of memory will be divided it into memory segments, that is in the form of 16 bit of segments. And the size of this 16 bit of segments is 64 kilobyte of each. And these segments are used to store the base address or starting address of our particular segments. We are also using our pointer register such as instruction pointer, stack pointer, base pointer, source index, destination index. These are used to store the offset address within the segment. And the offset address is our 16 bit of address. So these are the range of addresses are given. For the base or segment address, range starts from 000H to F00H. These are the 16 bit address. And the next one is offset address. The size of the offset address is also 16 bit, and the address starts from 000H to FFFH. And now the physical address size is 00000H to FFFFH. So these are the starting and ending locations are given for the base address, offset address, and the physical address. So our physical memory started from this 000H to up to FFFFH. And whole memory is divided into different parts, and each and every segment is having their own starting address and the ending address. For each and every segment is having their different memory locations of their starting and ending locations. But each and every location is having their own size, that is 64 kilobyte of size, and this space is there that is vacant and that is not allocated for any of the segment. This is also your vacant space and this is not allocated to our any of the segment, and that will be reserved for any different kinds of operation that is performed with your microprocessor. So that is the concept of our memory segmentation. So in case of memory segmentation, we are dividing our whole memory, physical memory, that is 2 raised to 20 equal to 1 megabyte of memory for your different segments. So why we are using the concepts of segmentation? These are the advantages of your segmentation. With the help of segmentation, multiple users can share the multiple location with the help of this concept of segmentation. Your program and data that can be separated with the help of this data segment and the code segment. So this data segment is used for declaration of our data variables and our code segment is used for writing the actual code of our program. So program and data can be organized with the help of these segments. We can allow multiple processes to share the data. The address of the processor memory that can be extended with the help of this segmentation. We can program or data more than 64 kilobyte of byte of data with the help of more than one code segment, and data segment can be used together in one particular program. If this program requirement size is large, then we can use multiple code segment as well as multiple data segment. So the size can be extended from 64 KB to onwards. With the help of segmentation, it is possible to write a program which are dynamically relocatable also, and it is also independent. So these are the advantages of our memory segmentation. So it is very helpful to organizing our information, organizing our data, organizing our code. That's why we are using the concept of the segmentation in our 8086 microprocessor.